Good afternoon, everybody. Thank you very much for signing up to the final webinar of the day for Warm Homes Week. We appreciate you taking the time out to join us. My name's Chris Ellis. I'm NEA's Training and Assessment Manager, and on the panel we have Paul Rogers, who is NEA's Innovation and Technical Evaluation Coordinator, as well as Michael Hamer, who is NEA's Innovation and Technical Evaluation Manager. So throughout the process of the hour, I'm going to do a little bit of introduction, and the lion's share of the work falls to Paul, who will give you a bit of an introduction to the work that we've been doing, of how we address the knowledge gaps and the skills gap around kind of the themes around decarbonisation. So for many, many years, NEA has been trialling technologies through our innovation and technical team. Well over 20 years of experience of going through these types of technologies, and just as importantly, understanding the learnings and the impacts of these technologies that have upon fuel poor and vulnerable householders. So for the last few years, NEA's kind of training team, as well as the technical team, have been working together to produce a resource for the sector to embrace and understand all the learnings that we have as an organisation and our partners, to produce a series of modules and a series of resources that hopefully will allow partners and decision makers and frontline workers, or anyone who's involved in or going to be involved in the decarbonisation agenda, to understand the impact of these technologies and what works, what doesn't work, what the pitfalls are, what are the impacts on the householder. Because we feel it's really important that the householder is the heart of the decision-making process, and really that the householder understands what these technologies are. Because without that understanding, there's a real risk that these particular technologies may either fail, or installation or installation projects may well go a little bit of awry. So we came together as two departments to create this type of resource. And as a result of this, we've now worked with NCFE, who is an awarding organisation, to produce a level 4 course and qualification. And that's a series of 8 modules, which Paul will take you through and give you a little bit of a flavour of what the course is about, and kind of a bit of evidence about kind of what we found through our kind of innovation projects. So without kind of further ado, I'll hand over to Paul to take you through the presentation. But both myself and Michael will be monitoring any particular questions. Now, we may not be able to answer all the questions, but we'll do our best to kind of monitor them and get back to you as soon as we can. If we can't, then we do have a recording of the particular questions, and we will get back to you post the webinar if need be. So without further ado, if I can let Paul take over. Thank you, Paul.
Okay, thanks very much, Chris, for a great introduction. So I'll just try and get the PowerPoint presentation up. There we go. So hopefully you should all be seeing that. If I go slideshow, right, there we go. Hopefully you should be all seeing that in full screen. So yeah, this is sort of a presentation about sort of the reasons why we developed the Decarbonising Homes course, and a background on and summary of what we've put together. So in terms of an overview of the presentation, I'll start by discussing the driving force for decarbonisation, which have led to the need to decarbonise homes. This includes greenhouse gas emissions and UK government policy, which is driving decarbonisation. I'll then discuss the development of the Decarbonising Homes course and how it used experience that we've gained from evaluating energy saving and renewable technologies. Also provides some details about the 80 learning modules that make up the Decarbonising Homes course, and I will also include some case studies from the module. So we'll start by looking at the environmental and policy driving forces for decarbonisation. So this graph plots annual CO2 emissions since 1751. Carbon dioxide emissions have risen substantially since the 1960s, and the cumulative emissions since 1990, which are shown in orange, are now greater than those between 1751 and 1990, which are shown in yellow. Annual global emissions of carbon dioxide are continuing to rise, despite us knowing about the risks of climate change for decades. Here we see the level of CO2 in the atmosphere, which has been measured by the Mauna Loa Observatory in Hawaii. When they started measuring CO2 levels in March 1958, the monthly average level was 315.7 parts per million of CO2. By May this year, it had increased to 419.1 parts per million. Studies of air trapped in ice cores have shown that carbon dioxide levels before the Industrial Revolution were at about 280 parts per million. This means that carbon dioxide levels have risen by about 50% since the Industrial Revolution. This graph is from the Intergovernmental Panel on Climate Change's AR6 report, which was published earlier this summer. It shows the change in global surface temperature relative to the period 1850 to 1900. The global surface temperature was an average 1.09 degrees C higher in the 2011 to 2020 period than in the 1850 to 1900 period, with larger increases on land than the ocean. Whoops. In the coming week, we'll hear more about the UN Climate Change Conference, COP26 in Glasgow. Countries are being asked to come forward with ambitious 2030 emissions reduction targets that align with reaching net zero by the middle of the century. Countries are being encouraged to accelerate the phase out of coal, curtail deforestation, speed up the switch to electric vehicles, and encourage investment in renewables. This will lead to new policies in the UK and around the world which build on existing targets. So I'm just going to try something. Whoops. Oh, actually, I need to go back. Right, let's try a poll. So if I launch that, hopefully you can see the poll. And the question is, which sector in the UK had the highest greenhouse gas emissions in 2019? So hopefully a few of you should be able to respond. Give you a few more seconds. Right, so okay, I'll just end the poll in a couple seconds more. Okay, that's great. So there's right. So if you see the results, it's actually quite a wide range of distribution on what everyone thinks is the highest emitting sector. So the majority think it's residential, with surprisingly agriculture coming second, transport third, energy supply coming last. Okay, well let's see what it actually was. Okay, so you can see from the infographic on the right that the largest was actually transport with 27%. So the Department for Business, Energy and Industrial Strategy publishes annual statistics on UK greenhouse gas emissions. In 2019, the UK emitted 454.8 megatons of carbon dioxide equivalent, with 80% of the contribution coming from carbon dioxide. They also look at the contribution from different sectors, and so as you can see, transport contributed 27% of emissions, the highest, with road transport the most significant source of these emissions. Emissions from the energy supply sector made up 21% of carbon emissions. Now, emissions from this sector includes electricity use in the home, including those from off-gas grid homes which are electrically heated. Emissions from the residential sector made up 15% of carbon emissions. Now, this is primarily combustion of fuels for heating and cooking. So, for example, that's going to include all the emissions from gas boilers and gas cookers, for example. 95.4% of houses in the UK have central heating, with 83.4% of these homes fueled by mains gas. So this graph shows the change in UK greenhouse gas emissions by sector between 1990 and 2019. So you can see that the most dramatic change is seen in power or the energy supply sector, which is shown in the graph in red. Emissions from this sector fell by 66%, mainly due to a decline in the use of coal for power generation and the rise in use of renewable generation. There's little change in emissions from surface transport, which is shown, I'd say, mid-blue, really, over this time period. And there's a small reduction in emissions from buildings, which is shown in orange on the graph. So we can see there's been considerable progress in decarbonising the electricity grid, but significant progress is needed to decarbonise transport and heating of buildings. So UK government policy is aimed to encourage decarbonisation by setting long-term targets. The Climate Change Act in 2008 sets a target of at least 80% reduction in the net UK carbon account by 2050. It's also set up the legislation for the Climate Change Committee. In 2019, the Act was amended to be at least 100% lower than the 1990 baseline. Whoops. In November 2020, UK government outlined their 10-point plan for a green industrial revolution. This included targets to increase the capacity for offshore wind generation to 40 gigawatts by 2030, to develop 5 gigawatts of low carbon hydrogen production by 2030, and to end the sales of new petrol or diesel cars or vans by 2030, encouraging the transition to electric vehicles. There's also a focus on encouraging greener buildings. This includes the Future Homes Standard, where no new homes will connect to the gas network from 2025. Instead, they'll have high levels of insulation and low carbon heating, such as an air source heat pump. There's a target to reach 600,000 heat pump installations by 2028. Now, this will be a challenging target, as it's about a 20-fold increase in less than 10 years. There's a social housing decarbonisation fund, and this is expected to provide £3.8 billion over the next decade in several waves, with 160 million available in wave 1, which is currently open. The Green Homes Grant Local Authority Delivery Scheme is a scheme for low-income households with lower EPC rated properties. There's also the Home Upgrade Grant, HUG, for off-gas grid areas, which we heard about yesterday. These schemes are set up in the form of competitions, which require local authorities or landlords to write competitive bids. The energy company obligation has been extended to 2026, with Eco4 starting in April 2022. Government has introduced minimum energy efficiency standards in the private rented sector, where domestic privately rented properties must be EPC band E or above, unless they have an exemption. government has consulted on a new target for EPC Band C by April 2028 for new and existing tenants. So we've seen there's a need to decarbonise homes, and there's funding available and energy efficiency targets to be achieved. So I'll now discuss the development of NEA's Decarbonising Homes course. NEA has been investigating technologies to improve the energy efficiency of homes for many years, and our innovation and technical evaluation team continues to work on projects evaluating the latest technologies for decarbonising homes. We gained a lot of knowledge about the performance of renewable and energy-saving technologies through the Technical Innovation Fund. This was a £5 million programme where innovative measures were installed in fuel-poor homes using funding from Energy Industry Voluntary Redress. The programme began in April 2015, and the last report was completed and published in April 2019. There were 46 different projects with over 2,200 households receiving a measure and over 2,700 different measures installed. In the programme, there were 19 different heating products installed. There were 7 energy storage products, 8 fabric improvements, such as external wall insulation, 10 smart heating controls, and 15 complementary products, sort of a range of different things such as radiator, fans, and devices to remove air from central heating systems. A sample of households received installations on which were receiving installations on each project were selected for monitoring purposes. NEA staff interviewed residents at the start and end of the project. Monitoring equipment was also installed. Energy meter readings were also collected for a period before and after installation. The monitoring period was typically between 1 and 2 years. This enabled us to gain understanding of the performance of a wide range of technologies in social housing and the problems which can occur during the installation projects, along with issues that residents may have. The NEA Innovation and Technical Evaluation team produced 38 Technical Innovation Fund reports, which are available on our website. Now, in discussions between NEA's training and innovation and technical evaluation managers, it was felt, as Chris described, there was a need to develop a series of training modules on technologies for decarbonising homes. The course would aim to provide a practical understanding of a range of low carbon and renewable technologies and their impacts and how they can help people living in fuel poverty. Content would combine insights from NEA's own extensive experiences of trialling the use of innovative technologies in low-income and vulnerable households, with data from other recent prominent studies. The Decarbonising Homes Technologies, Impacts and Solutions course is made up of 8 e-learning modules. There's also a brief introduction module to the course, which can be accessed prior to each of the main modules. The modules are solar and energy storage, insulation, heat pumps, boilers, heating controls and technologies, biomass, combined heat and power and heat networks, electricity tariffs, electric heating, and tackling fuel poor homes through decarbonisation. So the e-learning format allows us to provide engaging content with text, activities, audio and video. We've also been able to provide links to relevant documents and websites where learners can find more information. Learners are provided with a handout for each module, which is typically at least 40 pages long. This all increases the amount of information provided and makes a more interesting course with the flexibility of online access. If learners have any issues, they can receive email support from an expert tutor. So, who's the course for? Well, the course is suitable for a wide range of people who have an interest in technologies for decarbonising homes. This includes energy and sustainability managers, planned improvement or maintenance managers who have a role in specifying or organising retrofits of technologies for decarbonising homes. It could assist those who are applying for grants such as the Social Housing Decarbonisation Fund or Green Homes Grant LAD scheme. Of course, would be a benefit to housing and tenant support staff or surveyors who encounter residents who are having retrofits to their homes. These staff may encounter residents face-to-face or communicate via the telephone. The modules could also provide useful CPD for domestic energy assessors, retrofit assessors, and retrofit coordinators. It's also relevant for community energy advisors and volunteers who may advise residents with systems. The course could also help policymakers better understand the technologies and issues which occur with installations in fuel-poor homes. Could also assist councillors and those working for local authorities who have an interest in housing and decarbonisation. Decarbonising homes is a level 4 course. Content's at a higher level than our level 3 energy awareness course, and there's a lot more content, and it's a more in-depth course. Learners who complete a module will receive a certificate of achievement. The modules are now CPD certified and will typically offer between 3 and 6 hours of CPD. Learners will have the opportunity to complete an online open book assessment for each of the modules. Upon completion of all 8 modules and assessments, the learner will achieve an NCFE level 4 qualification. These assessments will be made available later this year. It's possible to get certificates of module credit for those who wish to complete individual modules rather than the full course. So I'll start by giving you some examples of the format of the online content for the solar and energy storage course. So I'll just try to get into the website for that. So hopefully there you're all able to see the web page for that. So each module has a main menu which can be used for navigation. Clicking on a home button, which will appear on the next slide, can take you back to the main menu. So if I go on to the next page. So the solar and energy storage module discusses solar PV, electricity storage for batteries, and heat storage in the form of solar thermal systems, solar immersion controllers, and heat batteries. It considers the impact of technologies on household bills, installation best practice, and potential operational issues, along with resident engagement. So pages have interactive content or multiple panes of information which you can you can access by clicking on them. So you can see on the screen here at the top, it says repeat click text area for more information. So if I repeat click this, you can see it's gone on to a new pane, got a graph here, and also it'll take, certain pages will take you to references of reports and websites. So if I click on the blue link at the bottom, hopefully you'll be able to see it take you to a web page on the MCS website and a report there. So if I go, hopefully I'm now back on the training web page. So this particular page has a jargon buster. So we can click on any of these particular terms to find out more information. So for example, FIT, we find that refers to the feed-in tariff, the government scheme, and MCS, which we went to their website earlier, that's the microgeneration certification scheme. So moving on to another of the sampled pages from the course. So here we've got an introduction explaining the components which make up a solar PV system. There's a degree of interactivity here. So we've got orange hotspots, and just to check that you can check what the name of the different components are by clicking on the orange hotspots. So clicking on the first one, we see that solar PV panels. This particular one here is the inverter, and we've got generation meter here and consumer unit. So this is an activity which learners would estimate the annual PV generation for a particular solar PV system. So in the blue box at the top, we've got an equation. So using that equation along with the table on the right, it's possible to work out, estimate the annual PV generation. And you're able to check whether you get the right answer by clicking on this red box. So if we click on the red box, it tells us the annual generation for the system described in this bit of text in the middle is 2,952 kilowatt hours, and it shows how the calculation was obtained. So this is an activity which sort of looks at some examples of poor solar PV installations. So the one on the top left, you can see that the solar panels are too close to the edge of the roof. In fact, one of them's actually sort of extending over the edge of the roof. So fortunately, this isn't a British installation. It's one in the United States. But by clicking on the image, we see a description of the issue with that particular solar PV system. The one on the right, you can see there's a small solar PV system on the roof. I think it's only 6 panels, but there's a tall chimney right next to it. So that tall chimney is likely to provide significant shading for the small number of solar panels. So it describes the issue of shading there. And the other two also have descriptions as well. So this is the last of the example pages from this module. And it's an activity where you drag the description onto the photograph of the correct meter or monitor. So if we start off with the standard generation meter, put that one there, smart generation meter here, and household PV monitor there. And so we're told that we've got the correct answer, and it's then in the e-learn you're able to move on to the next page. So that's an example from that module, the actual pages. So what I'll try now, let's see if we can do another poll. No, I'm not sure this is going to work actually. Yes, it looks like, oh, hang on, nope, poll 2, that's fine. So hopefully this one's open. So the question is, which of the following PV systems is likely to have the highest annual generation? Okay, so I'll give you a few more seconds. Okay, that's great. Right, I'm just ending the poll now. And right, hopefully you've seen the results. So the majority of people, 81%, have said that solar panels facing south and inclined at 30 degrees are the ones which have the highest generation, and that's the correct answer. So I'll move back to the presentation. Right, so hopefully that's now back in the presentation, and got a case study. Here we go, from that particular module, which is quite interesting. It's based on solar PV systems installed on a series of parallel terrace bungalows. There were 16 solar PV systems of comparable size, same orientation, inclination, and installed at similar times. You'd expect the generation on these systems to be quite similar. However, that didn't prove to be the case. So in practice, the annual generation ranged from 1,695 to 2,700, just over kilowatt hours, quite a wide range, much more than you'd anticipate, but based on systems being so similar. And we also looked at the total generation up to the beginning of 2018, and that ranged from about 7,900 to over 15,600. So massive differences in performance of these solar PV systems, but that they're meant to be performing the same. So the issues that caused this were partly due to shading of some of the PV systems by trees and bushes, but also due to failure of inverters. So there were inverter failures, and these weren't picked up terribly quickly, and the repairs weren't done that quickly. So it could be a period of months that the PV systems were down, and this meant there was, the landlord ended up losing feed-in tariff income. The residents ended up paying higher electricity bills than they need to have done, and also there were higher carbon emissions. So it was sort of people losing out on several different factors. So moving on to the insulation module. So hopefully should be able to do another poll here. Okay. So which part of an uninsulated house is likely to have the greatest heat loss? So that if anyone's done the NEA Level 3 Energy Awareness course, hopefully you will have come across this question before, and it's also briefly covered in this course as well. So I'll give you another couple seconds to put an answer in. Okay. So that's interesting. So 55% saying the greatest heat loss in an uninsulated house is through the roof, and 42% of people saying the walls, 3% windows. Well, if you've ever seen these sort of images of heat loss in buildings, which have different percentages on the different components of the house, normally it's down as the walls being the area with the greatest heat loss, and for an uninsulated house, it's typically estimated that I think it's a 35% heat loss through the walls and a 25% heat loss through the roof. So move on to some information about the insulation module. So start off looking at sources of funding for insulation, then discuss different methods of insulation such as cavity wall, solid wall, loft and underfloor insulation. Then look at different insulating materials such as rock wool, polystyrene and products offering higher levels of insulation such as Celotex, Kingspan and other things like aerogels. Module also considers how heat transfer is quantified with thermal conductivity or lambda values and also U values. There are case studies for external wall insulation and underfloor insulation. And finally, we also look at a whole house approach, such as energy sprung retrofits and passive house buildings. So one of the case studies is on park home insulation. Now, for those of you who aren't aware, a park home is prefabricated single-storey property, which is located with others on a site. They're often off the gas grid, and older park homes may be poorly insulated. This means that park home residents are highly likely to be fuel poor, and they can be quite vulnerable, with many of the residents being elderly or disabled. So this graph shows levels of resident satisfaction before and after two different brands of park home insulation were installed. Level of satisfaction before the installation is shown in green and blue. Satisfaction after is shown in purple and red. Residents were asked how satisfied they were with how warm it gets when it's cold outside. That's the top question. The middle question was cost of running the heating system. And the bottom question was how well the house keeps the heat in when it's cold outside. There was clear improvement in resident satisfaction on all these points, but it was most apparent on the question about how well the house keeps in the heat. Residents went from being somewhat dissatisfied to most being very satisfied. So on this project, there were very high levels of resident satisfaction. In fact, it was the best performance probably in all the Technical Innovation Fund projects. Average savings in gas consumption were just under 20%. Based on the heating cost savings alone, the payback time for external wall insulation at the time, before current gas price increases, was over 40 years. However, there were additional benefits from the installation. There was improved appearance of the property and potentially an extended life for the property. There was improved soundproofing. There was a reduction in condensation and mould, and the warmer temperatures in winter and cooler temperatures in summer led to better health for residents. So briefly look at the heat pump module as well. So let's see if we can get the last of the polls. So this one's a question for those of you who might know a bit about policy for renewable energy. So this question is, over how many years is the domestic renewable heat incentive paid? Okay, right, I'll end the poll in a couple seconds. Right. Okay, so hopefully you can see the results. So a lot of you know your policy for the RHI. So domestic RHI is paid over 7 years, with 73% of people getting the right answer there. A few people said 20 years, and that was the length that the non-domestic RHI is paid over. few people have said 25 years. Originally, when the feed-in tariff was introduced, that was paid over 25 years, but later it was reduced to 20 years. So, okay, so the heat pumps module discusses sources of funding such as the renewable heat incentive and the upcoming clean heat grant. It looks at different types of heat pumps and discusses lessons from projects with the technologies. These include air-to-water heat pumps, ground source heat pumps, hybrid heat pumps, and air-to-air heat pumps. We look at installation and system design and the need for correct sizing of the system and the importance of insulation and suitable heat emitters. The module considers the impact of installing a heat pump on running costs, thermal comfort and control. There's case studies from a variety of different projects, and it also describes advanced systems using heat pumps, such as combining heat pumps with heat batteries and electrical batteries. Also, the impact of complementary technologies like solar PV. So I mentioned earlier about a hybrid heat pump. For those of you who aren't aware, a hybrid heat pump combines a boiler with an air source heat pump. In this case, the system can automatically decide whether to operate the air source heat pump or the boiler, or both at once, depending on the outside temperature and the price of gas and electricity. A report by Element Energy on hybrid heat pumps noted that the heating schedule set by the resident could significantly affect the proportion of heat provided by the heat pump, and so the savings in carbon emissions. A twice-a-day heating schedule required bursts of heat, which would be mainly met by the boiler instead of the heat pump, while a continuous heating schedule allowed the heat pump to operate for a greater proportion of the time as it was maintaining the rooms at temperature. And this allowed for greater emission savings compared to a pure gas boiler. A Technical Innovation Fund project installed hybrid heat pumps in solid wall terraced houses. In some properties, the existing radiators were retained, while in others, new oversized low temperature radiators were fitted. Both types of installation were set to have a flow temperature of 55 degrees C. The properties that kept the radiators used a higher percentage of gas to meet demand, and this was on average 84%. Those that received new radiators used on average 59% gas for the heating, resulting in lower carbon emissions. The seasonal performance factor was only 2.11 for the households with existing radiators, but rose to 2.7 on average for those with new radiators. There's also a module on boilers and heating controls and technologies. The module starts with an overview of the components of traditional heating system, looks at developments in boiler technology which have made them more efficient and help reduce carbon emissions. This includes condensing boilers and additional technologies required by the Boiler Plus standard. As a result of decarbonisation, there'll be a transition away from gas boilers for heating homes. One of the alternative options will be hydrogen boilers, and these will be are discussed in the module. A range of different smart heating controls are reviewed, and their impact on household bills and thermal comfort are discussed. Finally, the module looks at technologies which are added to wet central heating systems to reduce air and build-up of sludge in the heating system. So Smart thermostats can be popular with households. There's a quote shown is going to be from a resident who had a Netatmo thermostat. She said, the Netatmo is really easy to use. When in a chip shop after coming home late, I was able to turn on the heating and avoid coming home to a cold house. She also said, when she was at Luton Airport, when going on holiday in the winter, I was able to set the heating to frost guard, which gave me peace of mind. So there's also challenges with offering smart thermostats in social housing. So as we learnt earlier, there are issues around digital exclusion, and that there's problems for those who don't have access to the internet and a smartphone. If you're going to have a smart thermostat, many elderly residents may have neither broadband or a smartphone. A resident might, we also found residents might not allow the smartphone to connect to their broadband or be concerned about the data that's produced. There are issues if the resident switches broadband provider, as there's potential to lose control of the thermostat by phone or the web portal. If the batteries go flat, the smart TRVs would no longer have power to move the radiator pin. This means that the radiator could be left running too hot or too cold until the batteries are replaced. If a new resident moves in, there'll be a need for them to be trained on use of the thermostat. This might be through information leaflets and support from a tenant liaison officer. A new account for the system may need setting up, and residents may need to download a phone app. Smart thermostat manufacturers often claim savings of between 20 and 40% on their websites or in adverts. These can be based on simulations which are not realistic or use examples of best case scenarios. In practice, the greatest savings tend to occur in homes which are overheated. This might be from having the thermostat set too high or having the heating on for longer than necessary. Many fuel poor households underheat their homes with the heating on as little as possible. Adding a smart thermostat is likely to result in improved levels of thermal comfort, but potentially lead to increased heating bills. So the final module I'm going to discuss in this presentation is tackling fuel poor homes through decarbonisation. This module ties all the others together, really. It provides an introduction to climate change, and you saw some of the information that was from that included earlier. It looks at household and organisation carbon footprints and how you might obtain them using a carbon calculator. The module considers emissions from electricity, heating and transport. Shows you how to calculate carbon emissions from an electricity or gas bill or journeys by different modes of transport. It also provides examples of how different technologies can reduce carbon emissions. So I will finish now with a short case study which looks at a semi-detached house, which is mostly solid brick walls. Property has an ENGIE score of 70 and is in EPC band C. The estimated space heating demand on the EPC was 13,209 kilowatt hours per year. The EPC also showed that if solid wall insulation was fitted, it estimated that there would be a reduction in space heating of 3,364 kilowatt hours per year. So it's therefore possible to estimate the annual carbon savings from installing the external wall insulation on the property. So we know that the estimated annual gas reduction is 3,364 kilowatt hours. Now, the government publishes a spreadsheet of greenhouse gas conversion factors, and the emissions from burning 1 kilowatt hour of gas are 0.184 kilograms of carbon dioxide. So if we multiply the reduction in gas consumption by the emissions factor, we find that the carbon savings are 609 kilograms of carbon dioxide per year. So that's the end of my presentation. Thanks very much for listening. You can find out more information on our website or by emailing technical@nea.org.uk. So now our training and innovation technical evaluation managers will join us, and in the short time we've got available, we can have a discussion. So I'll stop sharing, and hello, Chris and Michael.
Well, thanks very much for that, Paul. I'm kind of suffering from a very rare affliction in the northeast. The actual sun's decided to highlight myself, so apologies if I'm squinting. Look, I mean, before Michael comes in, thanks very much, Paul. That was kind of really a summary of the amount of in-depth nature and the amount of work that's gone into creating these types of modules. And I think the kind of the messaging that we're looking to get across is around kind of the level of detail that perhaps we all need to be a bit more aware of when we're talking about decarbonising homes, and the varying different issues that need to be made aware to anyone who's being involved in this particular process, because it's perhaps not just a situation of installing a technology and thinking that's the end of it. There's the interaction with the householder, what tariff the actual householder needs to be on, kind of levels of insulation. A question came in around kind of the impact of insulation and moisture. So there's a whole load of kind of myriad of things that people need to be aware around decarbonisation, and it's not just a one shop kind of option. There's so many different things that needs to be taken into account. And I think kind of, Michael, if you want to kind of come in and just give a bit of kind of an idea of the kind of the experiences that you have in terms of the technical side of things around kind of the kind of the problems that have been highlighted and are highlighted in the training. Just kind of, if you want to kind of just a couple of minutes of update around kind of your experiences of the problems, but also the benefits of decarbonisation. We don't want to be highlighting being negative, but what we want to do is support the sector to be fully aware of the different issues, the positives and the negatives of how we move into the net zero kind of realm. So, Michael, if you want to kind of give us an idea.
That's fine. So, actually, there's one question there that I haven't answered, which probably covers just what you introduced there. Is that the complexities of introducing several measures at the same time are quite high, and this course doesn't really do that in terms of whole house retrofit, for example, which we very much encourage. So that has to be past 2030 and 2035 that covers that, because it's a very specialised thing. And it's very it's bespoke to the housing stock in scope. So we don't go down that route. Although a lot of the technologies we do talk about can be fitted individually, and I think that's just as relevant for the course, because they don't necessarily interact. So as Chris mentioned at the start, we've done a lot of evaluations over the years in NEA, and these are other people's projects as well as our own, and the findings are often very similar. So bringing householders along on the journey is absolutely critical. It seems basic to probably most people or everyone on this webinar now, but it's absolutely fundamental, not just so that they know what's happening and so on, but actually know how to control, operate, service and otherwise the technology that are being fitted. So that's that question. There was another question, actually. Paul can probably chip in with, are hybrid heat pumps available after 2025? Now, I believe they are still in scope, and fossil, gas heating will still be around, but it's also there for a couple of reasons, which the course goes into great detail on. So using the gas heating when the electric heat pump isn't very efficient in the height of the winter is one example, and grid balancing is another. So we've not touched on that.
I'd say it's likely that it's not covered in the Future Homes Standard, so probably not hybrids for new build properties, but being able to hybrids are better for older properties which might otherwise struggle, in the depth of winter with high heat loss, but able to sort of cope in milder weather. So that tends to be the application where it's used. And our colleague Bryony was discussing the electrification of heat project, and I think by far the majority of installations on that in Newcastle area were hybrids, weren't they, Michael?
There were indeed, yeah, surprisingly, but that was specified, by the heat loss calculations for exactly the reasons you've just mentioned. Yeah.
Okay. Well, thanks very much. Just to kind of final minute recap for myself. A question came in through on is the course available? The course is now available. If you go onto NEA's website and the training section, or follow the link that Paul sent you, we'll direct you to the appropriate kind of information. But it's on NEA's training website. The beauty about the course, even though it's in depth, it is supported e-learning. So if you do have queries, there's always going to be someone there to support the learner. And also because of the nature of the fact that it's e-learning, that people can dip in and dip out as and when. And it might be that some parts of the course for frontline workers maybe of a certain technical nature, they might not need to know everything about that. But what it will do is it'll cover hopefully a lot of the bases that you will need to be aware of if you're going to be involved in the decarbonisation journey. So with that in mind, thank you very much for attending. If you would like any further information, by all means get in touch by the usual way on the website or via the email. We'll be more than happy to have a conversation. I think just thank you very much to Paul and to Michael and to everyone who's signed up for this. I hope you found it really useful, and we'll look forward to engaging with you in the future. Okay, thank you very much now.
Yeah, thank you.